All right, good morning. This is Rick Loring, President of LMGi. I'd like to welcome you to a brief overview of an incredible new program from Siemens for aerospace and defense suppliers. The primary concept here is to maintain a digital thread between the OEMs and the supply chain. This digital thread, it removes ambiguity, ensures consistency and accuracy, and streamlines the exchange of data between all parties. We're going to record this session for review at a later time. And to get things started off, I'd like to introduce Jason Titcomb here at LMGi to give you a glimpse of this program. And we encourage you to follow up, and we can give you a lot more details on the program itself. Here you go, Jason.
Great. Thanks, Rick. So we'll get started. Well, welcome everybody. As Rick said, my name is Jason Titcomb. I've been here with LMGi for quite a few years now, and have a manufacturing background myself. Just like Rick, we've both machined parts, and we're familiar with a lot of the challenges that people run into in the manufacturing. Plus, we get to visit a lot of customers and hear their challenges. So we're really convinced that Siemens software provides some awesome solutions. So first, some of the challenges. The world's population's growing, increased pressures to manufacturers to meet these advanced requirements. According to some research, customization and personalization are going to drive how industry operates. So you're already starting to see it where you can choose exactly what configuration of a particular product you get. So, and millions of new customers are going to demand customization and personalization of goods. This is going to result in lots of new customers from regions requiring diverse features and pricing. So you're going to have to move towards solutions that can handle these complex demands. Some other trends that are being seen are environmental regulations and government regulations. They're growing. According to NERA Economic Consulting, in the past 10 years, they've doubled, and so that seems to be a trend. And adhering to these new mandates creates a burden on developing products and manufacturing them also. So it's always a challenge to find cost-effective approaches to meet these regulation-related requirements. In addition to globalization, globalization is also having an impact. Right now, we're already seeing it, but by 2020, they expect 80% of the manufacturers will have some global operations, compared to only 50% now. So the question for manufacturers needs to ask is, how can you keep up? How can I deliver more complex parts faster at a competitive price and ultimately stay profitable? It's not always an easy answer. So if you kind of examine the typical flow, the manufacturing process starts with input from part design data. Based on part model. Manufacturing engineering typically defines the plan that specifies how the part's going to be made, sends it off to the CAM guy, and also usually we're seeing more CMM measuring machines being driven. So the whole success of this manufacturing process becomes really obvious whether it's successful when it hits the shop floor. That's when the practical, all the theory hits reality, and do things really flow the way you thought they would. So we're going to show you some of the value of digitalization of your entire process. We'll look at how a digitalized product can help you address some of these challenges. So customers expect manufacturers to shorten their overall lead times. I saw this when I was working in industry, even 20 years ago, working with power generation. We'd produce parts, and everything was running great. And then we would hear that we have to they're going to actually pay us less to make these parts all of a sudden. So we need to come up with new, more efficient ways to manufacture the same parts. So this pressure to always shorten your lead time and improve production. So how can you do that, you know? You can start by streamlining your workflow by using consistent and associative manufacturing data. So NX allows you to do that very easily. Your 3D models and assembly setups and NC programs can be all connected and associative. So if the design ever changes, either in the fixturing or the design model, everything can update very quickly. And also working within a connected system, all the stakeholders, they call them, all the people involved in the team, different departments, working in a single software platform can interact and collaborate much more effectively. It essentially becomes much easier for the manufacturing team to drive design changes that improve manufacturability. Let me say that again. It becomes easier for the manufacturing team to drive design changes. So the manufacturing team knows how to make parts, and if they have some ideas about how the part design could possibly be changed, or maybe how the engineer chose to do the work holding on it, it benefits the whole company that all that information is shared. So by driving your entire operation with a digital twin of the physical parts you're manufacturing, you can enhance your efficiency. So Siemens likes to call this the model-driven process, and I think the term makes sense. So if you think about it, it all starts with either a drawing or a model of a machine part. Suppliers may provide this, but you will see here with this interesting kind of a graphic here that how this flows through. So the 3D solid part, either designed directly in NX or brought in from a foreign system. You define your process by using NX assembly. You see the part and model preparation. There's a very powerful synchronous technology that can be used to adjust the model, typically defeaturing, removing some complex areas but not altering the underlying design component. It allows your CAM person to more efficiently create programs and have those adjustments all recorded. So then it flows through to your CAM. Ultimately, you very quickly can produce shop documentation with a single click, and that flows out to the floor. Now, at the same time, you can have a different team leveraging the PMI data, which is product manufacturing information. So this is essentially the whole paperless idea, if you're not familiar with it, where dimensions and annotations are placed directly in the 3D environment, where they make more sense. Actually, it makes more sense to have them there. We'll talk about that a little bit more. And all that information can be transferred to the CMM. So feature control frames that have true position tolerance, that can be transferred to the CMM, the inspection programs, and it all culminates in when the part is produced by the machinery. It then goes immediately to inspection. There's no waiting. There's no bottleneck there because it all culminates right at that end point when you can work as a team using one connected system. So the model-driven process, it gives you a really efficient manufacturing cycle from prepping to production, and it has significant advantages using this concurrent workflow. Now, CAM specifically provides, NX CAM provides a variety of functionality, virtually anything you would need to machine any kind of part. Everything from your very basic 2.5 axis milling, which they have specialized tools for these very simpler operations to make the simple things easy. and then high-speed machining methods for difficult to machine materials, 6Al4V titanium, high-temperature alloys, ingonel wasp, things like that are really tough to machine, very common to the aerospace industry. 3-axis, 5-axis, even turbo machinery specifically for turbine-style parts. So pretty much everything you would need, NX has a solution in the CAM environment. Now, this is something a little different, but it's related to the PMI. This is in the latest release of NX. They've made a really nice enhancement. Technical data packages. It's a way to share information either inside your company, or if you're an OEM, it's a great way to collaborate from the aerospace company to the supplier. So technical data packages really just provide sharing. Now you can share through PDF, which is an accepted format that everybody's comfortable with, and leverage all that PMI information that you've already created in your model. So here's a quick little demonstration that I thought was really exciting. This is, think about how many drawings people already have. Here you can start within NX Drafting, and really what you want is to have your PMI annotations in the model, so you can very easily leverage this existing work that's in the drawing and push that right into the model. Of course, there's settings, but I'll just go ahead and click OK. Give that a second to process. This is almost magic to me. It's really cool. So this is what people refer to as PMI. So these dimensions and feature control frames and callouts are kind of hung directly onto the model faces that they're relevant to. And the model views that you're seeing here on the left are kind of analogous to drawing views. So I'll show you a little bit more on that in a second. So now, and you can create those yourself in the model environment, of course. That's just, I thought, was a great capability to go from drafting and pull all that work in, so you don't have to reinvent the wheel. So you want to be able to share this information now. So NX provides this ability to publish in either a JT format, which, if you're not familiar with that, JT is a Siemens open specification file format that has various levels of detail. So you can send a coarse representation or a very precise representation of the data, and it also can contain information like properties, metadata along with it. So it's a file specification. JT, if you ever run into that term, it's kind of typically a lightweight format, but it can even contain very precise data in the form of parasolid. So NX now is a very nice way to publish that information out, and to make sure you can get it the way you want, they've made it very easy for you to make your own templates. So here's just kind of a quick little example of what you would go through to make a template, for your company. It's kind of annoying that, when we're working with PDFs, it's kind of annoying to have to work with another piece of software. It's nice to be able to work within the same package here, as you can create tables and text. You can still work with the PDF forms if you want to, but that's just an example of the integrated template creation. So now, once the PMI is created, you want to just publish that out, and it's just one click and choose your template, and then I'm going to grab one of the stock templates. They're fairly vanilla, and then you get to select. You could do all the views, all these model views here, or you could in my case, I'm just going to grab a couple of them. We don't need to get too carried away, but you can see there's a number of options. There's a JT file format if you want to use the more advanced capabilities with that, or if you just want PDF, that's fine too. You can migrate. You can export, probably is a better word, property information, like in this case part number, and you'll see where that shows up in a minute. You can have whatever you want. As much, this is all in your template, because you saw it. After you pick your template, all this information, these placeholders will get populated. I'll just fill out a couple of things like my name, and this is where you would put attachments if you had some additional information, and then you just specify a location for the PDF. It's super simple. Give that a second to do its magic behind the scenes. You can see the progress there, and in a second we should have a PDF. I'll open that up and we can take a look at that. So it uses your standard Adobe Acrobat Reader, and because it's active content, Reader just wants me to acknowledge it's got active content. You see the attribute data came across, and this is an interactive 3D window. Very easy to rotate that around. Nice little thumbnails at the bottom. So these are related to the model views that were created. So they're just like drawing views, which is really cool. And this ability right here, when you touch an annotation, it highlights the face. So this is so much better than a 2D drawing only. There is no ambiguity as to what an annotation is really referring to. No interpretation of a 2D drawing. You probably have all seen 2 or 3 guys standing around looking at a 2-dimensional drawing, trying to decide what is really intended. So quite a few benefits there. I thought that was definitely worth putting in as it relates to aerospace and defense suppliers, technical data packages. So coordinate measuring machines, CMM, we're seeing those in use everywhere now. Quality control after the part is machined. You can often create your inspection programs right at the CMM, but the ability to leverage your digital twin and prepare those inspection programs beforehand can be much more productive. NX can automatically create complete inspection programs using that very same PMI, or product manufacturing information, that we just saw with the publications. So the data is embedded into the file, and it grabs it and creates the inspection paths. Yet you can alter those if you want to, and there's a number of samples delivered with the software of CMMs. There's a few machines delivered. You can definitely create your own if you want to. And not only that, but you can take and get a complete closed loop solution. So after the CMM inspects the part, it can gather the touch points, and you can read that back into NX and overlay the two and get a really nice comparison as to what the part actually measured versus your digital twin within NX. And maybe you need to adjust your work holding. Maybe you've got a little distortion caused by the fixture, that kind of thing. So this harmonization of part design and manufacturing is really a good thing. By using the digital twin, I probably say that a lot, but I think it's really a cool term. Allows you to harmonize everything from planning to manufacturing execution. It's going to reduce your lead time and improve on-time delivery rates. So production throughput depends on efficiency of the entire process. Inefficient machining, machine downtime, errors on the floor, they all impact throughput. To improve throughput, you need to maximize your resources. Use the latest programming techniques, your high-speed machining methods, and look for new innovative technologies. I never would have thought that I'd see 3D printers in machine shops, but so many of them now we visit have even a standard plastic fused deposition modeler. They use them for all kinds of things. It's truly a technology that's taken manufacturing to the next level. So NXCAM specifically, some awesome features to automate the programming process. Feature-based machining is part of the system. You can use it when you want to use it. It essentially will automate the creation of operations and tools and things like that you would create manually. So you can push that as far as you want to push it. It can recognize pockets and holes. You can use your PMI data to help it understand that a hole is very precise. It has maybe a 5/10 total tolerance, and it should be spot drilled, end milled, and then reamed instead of just a straight spot drill and drill. That information can be gleaned right from the tolerance information on the PMI. This can, I know it sounds crazy, but you can cut programming time by as much as 90% on certain types of parts that are well suited to this automated system. And also, you don't need to start every job from scratch with an NX. The machining data library allows you to kind of capture best practices or previous practices or whatever. If something's been done and it worked well in the past, it's very easy to reuse that and make it part of a kind of a knowledge-driven process. So even something as simple as just the templating within NX allows you to store how things are cut. So even you get a new person in, they can leverage these best practices without having to go in there and discover how to generate a particular tool path. And intelligent tool paths, meaning, the software has a number of technologies. If you have multiple parts in, say, a couple of different vices, the software knows how to transfer the previously machined resulting material onto the next station using this in-process workpiece. It even can be transferred out to an entire different part. So here's some other examples of NX-CAM functionality where they've focused prismatic parts. They've introduced in the past few years volume-based milling. So what that does for simpler parts that are very kind of blocky and prismatic, it gives you very quick feedback to your input. So when you change depth of cut or a step over or lead in, lead out, you get this kind of immediate previews. You get immediate gratification, so you don't have to do this kind of try it loop where you fiddle with settings, you generate the path, you verify, and then you say, oh, that's not what I want. So the volume-based milling shortens that whole cycle by giving you immediate feedback. And multi-part programming, you'll see in a demonstration in a second how it's really just a copy and paste workflow to reuse one operation and copy it to other, say, positions on a tombstone. Same part positioned in various locations on a tombstone. Doesn't even matter the orientation. And multifunction machines also. These minimize the number of part handling, right? So you can do turning and milling in one machine, so the human doesn't have to touch the part; it just runs. So you guys, I'm sure you know all about that. And then the simulation. Sometimes people will use third-party software. It's expensive. It's another piece of software. Not to diminish those softwares; they're awesome. But NX has amazing machine tool simulation that can read right off G code. And do your verification, excruciating detail right within the same platform. It's a pretty cool testimonial here from Telsmith. They make big parts. Big parts equals expensive. Mistakes get that much more expensive if your software is not optimized. That gets much more expensive. So by using Siemens software and controllers, they were able to increase their programming output substantially. Robotic machinery, we've also begun to see that everywhere. It seemed like the auto industry was the domain where you would see robotics. I remember seeing it on TV years ago. And it seems like everybody we visit now has a robot. I'm thinking about getting one for home to make me coffee and breakfast and stuff like that. But so yeah, the use of robots for machining in the shop. Not precise machining typically. Typically things like lifting, positioning, welding, things like that, you can use one for. But they're also used for low precision trimming, little grinding, deburring, polishing. They can greatly improve your productivity by taking advantage of these technologies. You're going to stay competitive. And even if you don't see that in your near future, at least you know that Siemens NX platform has that for you when you're ready as an integrated system. It's so much easier to learn for you to learn about robotics within NX once you already know NX. So you're not having to hunt for things. You're kind of familiar with the interface and it's all integrated. So it allow you to automate a complete manufacturing process. Additive manufacturing is another thing we're seeing. So we mentioned that earlier, 3D printing. People used to call it stereolithography. So this has obviously evolved into such a broad spectrum of techniques. They just now call it additive because stereolithography is kind of a polymer methodology. And so even you see in this video, they're spraying on this deposition of material is sprayed on with a laser probably in a little zero oxygen atmosphere. And according to one survey, 75% of companies are already adopting 3D printing in some way. It may not be as advanced as what you see on the screen, but we did recently visit a customer that had 3 or 4 3D printers for just fixturing, work holding. And hybrid manufacturing is simply the combination of a machine tool that can add material through whatever process and also subtract the material. So it allows you to do it all in one machine. You can actually produce parts that probably can't be produced any other way. You could have a very precise feature inside a completely closed volume of material that you added on. So you could stop at some point, machine some precision, continue to add material. And NX is leading the industry with this. They're working tightly with machine tool manufacturers to, here we see an example using NX Cam and DMG Mori to create an additive operation. The integrated simulation of the software, which you would typically see it removing material, is just simply used to simulate the addition of the material. I don't know how they actually do that. It seems like a tough computer problem, but yeah, they simulate the addition of the material and all the the parameters. These machines often have to vary the the output, the power that they spray this metal on. It can allow them to make you can make weak areas in the metal, which is really handy when you have to remove a part. If you can, with a plastic 3D printer, you can just kind of snap off the little supports, but when you're printing a metal part, it can be a bit of a problem to snap off your supports. Well, these machines can know to adjust the power to make the supports kind of brittle and fragile, so you can easily snap those off. So it's pretty cool. So having it all in one system and being able to add and subtract it's a game changer. Often, we see a lot of disconnected workflows in manufacturing. There's pockets of valuable information. People say, I don't know, that just happens over there in the CAM department. And, the flow of manufacturing information between people, departments, and technology, might involve paper, or, you know, a thumb drive. We still see a lot of that. And it shouldn't be any surprise that that can impact production. Until you actually maybe measure it or examine it, it might not really be obvious. And let's take a look at how you can kind of streamline this by using a single source of data and reusing proven practices. So having connectivity to your shop floor is awesome. So you can guarantee that when someone is consuming information on the floor, they're getting the exact information. Only the certain program, only the released program, only the proven NC program, things like that. So this is a pretty good graphic, kind of a data and process driven. When you think about storing your electronic data, you may hear the word Teamcenter. You may see it on the Siemens website. So whenever you hear Teamcenter is a complete system that can house your electronic data as well as protect it, regulate who can see it. You can also mimic all the processes that you would normally do now with paper or, you know, printouts. All those can be housed digitally in Teamcenter. So you can define your process sequences there. Much more efficient because everyone has access to the Teamcenter environment and they can all see that. Here is an example of the manufacturing resource library. You can also store all your tool information right in there in Teamcenter. So it's very quickly searched. You can know if a particular tool is maybe you forgot that you only have 2 of those tools and one's being used. Maybe they're both being used, or you know, even at the level of, do we need to buy more end mills because, you know, we're using a lot of these. So that manufacturing resource library in connection with Teamcenter gives you that awesome control. So, like I said, everything, CNC programs, tool lists, setup sheets, they all can be, they're all part of the manufacturing software and managed in Teamcenter. And it all needs to be transferred to the shop floor. So by extending your PLM to the shop floor, using, say, Shop Floor Connect or access to Teamcenter, people will only have access to the released CNC programs, for example, and the released drawings. They won't be accidentally finding some old bad version of a file. And the tool data management is awesome unless you ensure the tools are properly prepared. You can have very detailed instructions on how to set these tools up. So everything from this diagram, pretty good view of the complete solution that Siemens NX can provide. So let's take a look at a demonstration video here, which is kind of cool. With NXCAM, you get this full range of programmability. Here you're seeing what you'll see when you use your very efficient prismatic. This looks like a floor and wall type operation. You get immediate feedback on the cut levels you saw there a second ago, and the same with hole drilling and pocket milling. You'll see a preview of the volume that's going to be removed. Multiple setups here. You can see that the material is it's transferred from one to the other. Same part held in different positions. The software knows that the material is passed on to a certain way. So multifunction machines. This is probably kind of a quick video, but this is a really good example of complex turn mill turn machine. This one even has an articulating B head on it. Here's a little pinch turning secondary chuck. You even notice that the chuck's spinning is simulated This is an example of your manufacturing resource library within Teamcenter and how you can very quickly find and navigate all your tools in one slick environment. Here's another great example of automation. You in your CAM, NX CAM, you can create one programming sequence on one part, and you really just need to repeat this on other parts. And notice that the part on the right is actually rotated 180 degrees just because it's easier for fixturing or whatever. So paste inside with reference, it's going to pretty much mimic whatever happens in the first set of operations. And if you change the original, it changes in all the others as well. And then when you simulate it, it's based off the G code. So you can be guaranteed that the way the controller is going to react is going to be mimicked very accurately here within the software by working off that G code. Maybe you made an adjustment to your post processor, or maybe you did something a little different than what you normally do, that kind of thing. It's going to be picked up in your integrated simulation and verification. Here's an example of leveraging the CAD capabilities within NX. So having that CAD capability directly at your fingertips while you're involved in the manufacturing process is really nice. You don't have to sometimes maybe ask someone else to do it because they use different software or open up a different piece of software. You can create your drawings for your setups right within NX, all within one system. Maybe setup drawings, tool drawings. Shop floor documentation is really, as you see, it's just a couple of clicks, and you can customize this to suit your needs. The out-of-the-box formats actually seem quite good. They seem good enough for me, but people always want to customize them to suit their needs. And this is Shop Floor Connect. So this is how out there on the floor people can access that same tooling list or operation list that was generated and access just the current machining program that they should be using via Shop Floor Connect. Digitalizing your entire manufacturing process. Pretty cool stuff. So yeah, it's all about delivering jobs as planned. You want the plan to all come together. Another great testimonial from a German company that has used Siemens software and Teamcenter to greatly improve their processes. They improved cooperation among different divisions. For example, I mean, these machines are massive. Often these projects this big, you can't just put it together and try it and see if it works before you ship it. It's assembled at the customer's site, you know, some of these big engineering projects. So you need to make sure things are right. You can't show up and not be ready. So yeah, you can digitally transform your production and become more competitive. Digital manufacturing provides these advantages, you know, to harmonize your part design and production, maximize your production efficiency, and get those jobs delivered faster. If you want to learn more, the NX manufacturing forums and design forums are all open. If you want to see what people are chatting about, there's information on the Siemens website. There's even a Manufacturing 360 app, which is really cool. The forums are open for anyone to look. If you just need to have a login to post information, which is nice, so they're not full of ads and junk. It's all real users doing real work in the forum. And if you'd like to speak with a sales representative, John Balconi is your guy, Vice President of Sales. I'll let that information linger there on the screen. You'll all be sent a follow-up email from the GoToWebinar anyway. That should have all this information on it, and we'll make this replay available so that you can watch it at your leisure if you weren't able to make it today. And with that, I'd like to thank you for your time. Thanks for coming, and have a great day.